Hi everyone, this is Amy Blafer. In case you're not my student, I'm just going through the notes now. Any notes that you've already seen, you can just skip ahead in the video to where your notes ended and where what needs to be filled in is left. Okay, so let's kind of talk through inverses from the beginning to the end. So our first example that we're going to look at is how to represent the inverse of a relation. So what is the inverse of a relation represented in a table? So please recall that a relation, that is just a relationship between x and y values, which can be represented by a table or a graph or equations, is a set of all ordered pairs x, y, where the x is an element of the domain and the y is an element of the range. So for an inverse, please write inverse relation. So an inverse relation is formed when the roles of the domain and range are reversed. So what you want to write yourself a little note about here is that you're going to swap x and y, or another way you can say it is swap x and f of x. Okay, it just kind of depends on the way it's written. So if you look at this table right here, you will see that all they have here are my x and y values. And in order to find the inverse, all I did was swap all my x and y coordinates. Pretty straightforward, pretty simple. It says if an inverse relation is a function, if an inverse relation of a function f is itself a function, it's called an inverse function of f, which can be written as like it's got this cursive f with a superscript of -1 followed by parentheses of x. So that is how we denote the inverse function. So first thing we're going to do is identify the inverse relation, and then we're going to judge if it's a function. So what I'm going to do first is swap my x and y's. So this is going to be my original, and that's my inverse. Okay, so I'm just going to go through, swap them out, and then we'll make a judgment about the relationship. And again, all I'm doing is just swapping all my x and y coordinates. I'll double check my work here in just a moment. Okay, so all swapped. That looks good. Now the question is my inverse actually still a function? So there's a few different ways to do that. When you have a table of points, the easiest thing to do is to look for any kind of duplication in your x values. As you can see, each x is unique. So therefore, I'm going to say yes, the inverse is a function. Okay, let's go ahead and repeat that again over on this side. So again, I'm just going to swap my x and my y, and then I'll determine if it's an inverse. Okay, so in this case, this is not an inverse when I look at the function, like the inverse is not a function, and that's because I've got a duplication here. The value of x has two separate y values associated with it. So in this case, no, the inverse is not a function. Okay, so pretty easy when you have a table. You are looking to see if you have a nice duplication. All right, so at this point I'm going to get into a little bit of graphing. I have my graphing calculator, which I'll be using here in just a moment with us. But if you don't have a graphing calculator home, remember you can use Desmos. That's a free graphing tool. All right, so of course we know what the function x squared looks like. F of x equals x squared. That's just a nice U shape. You can see it right here. There is that function. It's graphed, it's a U shape. So what about the inverse of that function? So when I'm looking at a graph, an inverse is going to be a reflection across the line y equals x. So the line y equals x is the line that goes to the points 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. So that is a perfect line going up to the right. And so all I would do is reflect across that line all my points, again swapping my x's and my y's, and then I have my second graph. So this is my original, and this graph that is right here, that one is going to be my inverse. Now up above, it tells you what the inverse is. It's y equals plus or minus the square root of x. So let's go to our calculator on that one and take a look at it. So if I do just positive square root of x and I'm going to do graph, you'll notice I only get half the graph. So in order to get the other half of the graph, I don't have a plus or minus key when I'm using my calculator. I just put in negative square root of x. And now when I do the graph, it does the other side also. Okay, so that's why we've got both pieces. So that's what the plus or minus does for us. So how are these graphs, how can you represent this graph algebraically? The inverse is represented by this equation. Don't worry, I'm going to show you how to solve for it in just a couple minutes. How are the graphs related? They are reflections across the line y equals x. And that's what we see right here. That is all they are. Let's go over to the next page. Okay, so let's talk about how we're going to write this equation. So whenever I'm doing one of these, the first thing I'm going to do is I'm going to replace my f of x with a y. Then I'm going to swap my x and my y in my equation. And then I'm going to re-solve for y. Okay, so let's kind of walk through that. So when you're solving for something, you're going to undo your order of operations starting at the bottom. So I'm going to subtract 1. So I get x minus 1 equals 2y. And then I'm going to divide both sides by 2. That way I'm, again, isolating, divide by 2, not y. That way I am isolating my equation. So when I write this out, I'm going to have x minus 1 over 2 equals y. Now this is the inverse, so I want to note that. So I'm going to change that over to f of negative 1 when I put back my y. And so this is how I do that inverse. Now, if I want to do this graphically, that's going to be a little bit more complicated. What I'm going to typically do is select a few points. Now, this is a straight line, so I would really only need to pick 2 points that are on the line, and I'll swap my x and my y. So how can you use the graph of f to determine if the inverse is a function? Well, let's go take a look. Okay, so I'm going to put the inverse into my equation over here. So parentheses, x minus 1 divided by 2, and I'm going to hit graph. So graphically, I always use the vertical line test. So if I just want to check and see if something is an equation, it is a function, I am just going to draw mentally vertical lines and make sure that my vertical lines, no matter where I draw them, only intersect with the graph of the equation once, which it does. So I'm going to say use the vertical line test. That's how I determine it. And what the vertical line test looks for is it looks to see if each x value is unique and only has the y values that it's paired up with. It's not going to fail that test. Now you may be saying to yourself, well, what does it look like when it fails? Here's what it looks like. So here's that original graph that we saw. If we draw a vertical line right through here, you'll notice it touches the red and the blue line, both of them, which means it would fail the vertical line test. That means that your x value has multiple y values associated with it, so it is not a function. Okay? So what you're doing with the vertical line test is looking to see that each x only has one y associated with it. Okay. So that's what we're looking for in something like this. Okay, so you may be saying to yourself, how am I going to make sure that I draw these equations correctly and do them right? Let's kind of walk through that together. All right, so you're going to consider the function that's over here to the right, that typical U shape of x squared. So let's talk about where our problem points are going to be. So if we make an inverse, the places where we would make our inverse would be these values right here, and that will be problems for us. And remember, we're going to be swapping our x and our y's, so you'll notice that there are two values here that are going to be associated with the same height value. Now, it's a little hard to see on that, so let's take a look at it here. Here's what the inverse of this graph looks like dead on. So it says 2 and 2. So there's 2 up and down, and as you can see, there are two y values associated with it. I've selected these points because they come out nicely when you square root them. So if we had our inverse, and remember, here's what our inverse looks like. If we were to put 4 in right here, we would get plus or minus 2, which is what you see right here with our problem. So that means we need to get rid of our duplicated values. Now the way that we always do this is we always dump the negative side. So you'll notice over here that this has become dotted, and that's so that we know that that's the side we're going to be getting rid of. So we're only going to keep our positive side over here. So we're going to keep our values of x that are greater than or equal to 0. That is the half that's on this side. We're going to dump all the values of x that are less than 0. Now, when we do our test, we only have one section. Let's go look at it on our calculator. So when we dump this negative value, now our inverse will pass our vertical line test. So if you look down here, here is the same graph we were just looking at. So let's give it a try on this problem. So first thing it says is find the inverse with the appropriate domain. No problem. First of all, we're going to find our inverse. So I am going to take my problem. I'm actually going to factor this to make it a little easier. It's just a little bit of a trick. Okay, and I'm going to swap my x and my y. Remember, that's really y. All right, so now we got to solve it. So I'm going to square root both sides. Remember, this would be plus or minus. And I'm going to move the 4 to the other side by subtracting it. So, oh, yeah. So that's going to be, so my inverse comes out to be this. Now we are going to be dumping the negative half, meaning we are not using it. So there's my equation. Let's take a look at this graph. So if I had the plus or minus, turn this back on. Okay, so the red half, which is the bottom half of the graph, is the problem. So what we need to do is get rid of some values that are going to be problematic for us. Which values are they going to be? All of our negative values. So the values we want to keep are where x is greater than or equal to 0. Now again, if you're having a little trouble seeing that, remember we want to get rid of the negative half of the equation, so I'm going to turn it off. And we're just going to get rid of that bottom half. That's what you see right here. How do we decide what our domain is? We decide what our domain is because we go back to our original graph, which is that little beauty right there, and we get rid of everything that's on the wrong side of it, which are going to be our values of x that would be negative. So those are going to be our restricted values. So when we're looking at this graph, when we're doing this side of the equation, we want to make sure that x is greater than or equal to -4. That will prevent this half of the graph from happening. Over here, we just need to make sure that we use the values of x that are greater than 0. So a little bit of restrictions there. So here's our original equation right there. And here's our inverse with its restrictions. Oh, I cut off my -1. All right, let's try it again. All right, here's your original function. I'm going to get rid of this and replace it with a y. So that would look like this. Then I'm going to swap my x and my y. And resolve for y. So add 9. Square root both sides. So this is my equation. I'm going to rewrite it with that inverse notation. Now you'll notice that I just automatically dropped off the plus or minus. I'm not going to use it. Just makes my life a little bit easier. Okay, so let's talk domain restrictions. So going over to our graph, get those out of there. Remember, we're only going to do the positive. We're not going to do the negative. So looking at this graph, we want our x values to start way over here. Remember, I'm using a 10 by 10 graph. So anything for x that's greater than -9. Any of those are going to be fine, and we won't have any graph restrictions. outside of those for the inverse. And that's where hopefully you got to on day 1. Let's take a look at where we should be for day 2. All right, so day 2, and again, hopefully you've skipped over to this example so you can take a look at it. So we're going to find an equation of the inverse of this function. So this, find the equation of the inverse of that function. So we're going to kind of just, walk through this. So first thing I want to do is I'd like to see what my equation looks like. So I'm going to put on my line y equals x. Now let's just find some nice points. So clearly that's a nice point. That point is 2, 0. Let me see if I can find another nice point on this one. 6 right here. 6 is at 6, 2. All right, if I swap those, the x and the y, I would have a point that's here at 0, 2, and I would have a point that's at 2, 6, which is a little bit off. So I've done my inverse in that blue color ink. So that's what I expect it to look like. So if you look at the stuff that says here, it says the graph shows that no horizontal lines intersect the graph more than one point. When the graph is reflected across the line y equals x to produce an inverse, there will be no vertical lines that will intersect with the graph more than once. Since the inverse has exactly one element in each, for each element in the range, in other words, has an element for the domain, the inverse will be a function. So let's write that equation out. So how do you do this algebraically? You swap your x and your y. And then resolve. So first thing I'll do is square both sides. That'll get rid of the square root. And then I'm going to add the 2. Rewrite it with that fancy notation, with the inverse notation. Oh, looks like they want me to put it here, so I'll just put it down here. Okay, what about domain restrictions? So, easiest way to do it is to look at the graph. So as you can see with this graph, it is perfect as long as you keep everything to the right of the y-axis. So that would be x is greater than or equal to 0. Now, if you hadn't noticed it or caught on to it before, I want you to take a look at this little pattern. So if my original function, the domain is x is greater than or equal to 2, y is greater than or equal to 0, you can swap these when you do the domain for the inverse. Just remember to change that from a y to an x, and this from an x to a y, and it works out perfectly. Again, you can also use your graphing tools. All right, this one says find the equation of that problem that we want the inverse of. Okay, so algebraically, I'm going to swap my x and my y. All right, first thing I'm going to do is I am going to move the negative over to the other side. To get rid of a cube root, you cube both sides. And then you divide by 4. Now, I just want to point out to you here that if I cube that, that would give me 3 negatives. So negative x times negative x times negative x, which is the same as this. It's a lot cleaner to look at. So that's why people write it that way. So in this case, f inverse of x is going to be negative x cubed over 4. So that's what I have for my equation. Some people might also want to write it this way. You could also pull the fraction out front. Not many people want to do that, but I want to give that as an option for you. Please notice it's not asking you to do anything with the domain restrictions. And if you look at the graph for this, you can see that there's x on the negative side and the positive side. So there are no domain restrictions. So if you'd like, you can just write where x is all real numbers. There's a bunch of different ways to write it. That just makes it a little easier. Okay, let's take a look at one that's a little bit uglier. All right, so we have this little beauty right here. Here's what its graph looks like. It says sketch the graph of this function, okay? All right. And again, you can use your graphing tool to help you out. Let's find our inverse algebraically. Okay, there's not a lot of room for me to squeeze this in, but I'm going to make it work. So swap your x and your y. Resolve. So I'm going to subtract 2 first. I'm going to multiply or divide by -1. What that does is switch these two and change their signs. Cube both sides. And then move the one to the other side. Oh, hang on. Oh, I didn't put my, yeah. Let me fix that. Y. So I end up with y. So that means my inverse function looks like that. Okay, so what if I actually want to like graph both of them? Okay, so a little tricky, but not too hard. Here's your line, y equals x. So if you reflect across, this piece is going to do this. And if you reflect across this way, just kind of look at that little bubble there. If you go across the other way, it's going to just do this. So that's what it should do right there to give you a nice little graph. So that's just what your reflection would look like. Let's slide on down to a little bit more. And by the way, remember, if you want to, you can also put it in your graphing calculator. Okay, you'll have access to both. All right, so the final stuff that we have to do has to do with compositions of inverses. So first it says find the inverse, then it says how do you verify? Verify means prove that those are inverses. So first we're going to find the inverse. So I'm going to swap my x and my y, and I'm going to solve. So I know my inverse is this. Bam, done. Now, the next part of it is to verify. So verify has to be one of the most annoying things that we do because verify means you have to show that that is the inverse. Yeah, I know, I just found it, but that's not what verify is. Verify is you do f of g of x, and then you also do g of f of x. And if you have actually found the inverse, both sides should be equal to x. All right? And again, this is what verify means to do. If you do not do this, you do not get points for verifying because you haven't done it. All right, so when you're doing this, you're going to consider this to be your g of x function. Okay, that's what that's going to be called when we do it. So I'm going to do f of x minus 5 over 2. So that means I'm going to take this and put it right in here. So I will have 2 times x minus 5 over 2 plus 5. The 2's cancel. The minus 5's cancel. And end up with x. That's what I want to see there. If you've done it right, that's what happens. Everything collapses to x. All right, now what if we go the other way? So this time I'm going to do g of 2x plus 5. Okay, so I'm going to take the 2x plus 5 and put it into this equation. So 2x plus 5 minus 5 divided by 2. Okay, first thing that happens, those cancel. The 2's cancel. You're left with x. You have now verified it. Yeah, that's what it means to verify. This is to find the inverse. This is to verify the inverse. So if someone asks you to verify and you do not do what appears to be ridiculous, you don't do all those steps, you don't get the credit for it. Let's try it a couple more times and finish up our notes for today. So, are these two functions inverses? Verify, okay? You got to verify. That's your action verb there. You got to verify it. So, first thing I'm going to do is do f of g of x, and it better equal x. And then I'm going to do g of f of x, and again, it has to equal x. You can't just do one and not do the other. Okay, so I'm going to be doing f of the square root of x minus 5. So that will be square root of x minus 5 squared plus 5. Okay, so you have to FOIL that out. Like you actually have to sit there and FOIL it out. So you got to write twice and do the multiplication. So that is going to be x minus 10 square roots of x plus 25 plus 5. So that's x minus 10 square roots of x plus 25, no, plus 30. That's not equal to x, so it does not verify. It's not equal to x. So these are not inverses. Now, yeah, because that does not equal x. It does not equal x. So since it does not equal x, they're not inverses. You don't have to keep going. Now, what if this one equals x, but that one doesn't? They're still not inverses. They both have to equal x. Okay, let's test another pair. Okay, here's another pair for us. So again, I've got to do f of g of x, and I have to do g of f of x. And they both have to be equal to x. So that's f of 4x minus 7. So I have 1/4 times 4x minus 7 plus 7. Okay, so you got to distribute. So that's x. That's looking good. Minus 7/4 plus 7. Well, that's not going to be equal to 1. So these are not inverses. You may say, all right, how do you know that? Let me do the math for it. So I have negative 7 divided by 4. And then I've got the plus 7. That's a decimal. I'd like it as a fraction. So that is x minus 21 over 4. That's not equal to x. Not equal to x. So they're not inverses. I don't have to keep going. As soon as this one fails, I don't have to do the second one. Let's try one more. So again, I've got to do f of g of x, and it must be equal to x, and then I have to do g of f of x, and again, that must be equal to x also. Okay, so I'm going to do f of x cubed plus 1. So that is going to be the cube root of x cubed plus 1 minus 1. Okay, we're looking pretty good so far. Cube root of x cubed, that is x. Check. All right, so that part worked. Now you have to do the other half. So now I'm going to do g of the cube root of x minus 1. Okay, so that will be cube root of x minus 1 cubed plus 1. All right, the cube and the cube root cancel, leaving me with x minus 1 plus 1. So that's equal to x. That checks. So I can say, yes, these are inverses. And that is the end of your notes. So at this point, please go and finish the assignment for today. All right, go do today's assignment. Get it all finished up so that you can enjoy your snow day and be done with your snow day, and or sorry, like be done with your homework for math and get all finished with it. But that's kind of it. And I hope you all enjoy your day off.